can also be done using cloud-based services. And I talked about several cloud-based services, the most common ones being from Google, Microsoft, and Amazon. And so these ideas should carry over to those platforms as well. Right. So today I thought, just a reminder about the homework, right? So this is an Amazon tutorial, and obviously to do that, you should sign up for an Amazon account. And as I said, one of the advantages of it compared to some of the other cloud free tiers is that the the amount you get is probably the same, $200 or $300, but most of the others, the time runs out in 2 or 3 months, whereas here it goes on for 12 months. And hopefully after you, obviously get into a working situation, then you may not need, your company will sign up for all this. So these are the common this is a common 5-step process. We already know, before this, we didn't have to do this, right? If we were running on our own computer or using RapidMiner or scikit-learn or anything, then we didn't really need to do this first step, which is when you say notebook instance, it actually fires up a virtual machine and then runs Jupyter on that. So that's an extra step when you come to cloud-based services. Then we need to prepare the data, train the model to learn from the data. And we are mostly at this point talking about supervised learning. The extra step that we normally don't consider when we typically talk about machine learning or analytics is deploying the model. Right? We do talk about evaluating the model, but we don't really talk about deploying the model. So when you are running something on an instance that you create, that means a virtual machine that is booted up, and then we need to have some way, where are we going to deploy the model? And so these same steps will be covered in the 3 examples we do today. And I just said you need to first look at what the data looks like. And this is a very, very important mandatory thing. And then I also said, can you try some other ML algorithms? And I gave a link which points to, I don't know, about 15 algorithms that SageMaker has. But of course, we can use any other software. Okay, somebody said, who is it? Niroshanan says that he found that SageMaker is only for 250 hours, 2 months. Yeah.
Available for 2 months. After 2 months, it will be charged. They won't notify, it will automatically charge. And also, only the medium instance is free. They don't restrict it. But if you use the other instance, I was charged when I used it. Not for this, I did earlier, so I was charged.
But if you are within your limit, then of course, because I think I showed that for the training part, it's good to use a bigger machine, for instance. And then, of course, you will be charged for it, but it is from your free tier. And 2 months, that Maybe it's because you are going on the commercial. So there is something. I need to find out how you get the 12-month thing. Yeah, I'll post it on here. Okay, so other than the ML algorithms that are in SageMaker, of course, you can use, since now you're using a Jupyter notebook, you can use, I don't know, scikit-learn or TensorFlow or anything like that. Algorithms from those libraries. But the most important thing is to shut down your instances before leaving, because otherwise you will be charged. So it's like as if you're having a server running, waiting for some requests or something. So that has to be charged, and therefore you need to always make sure you shut down those instances. Right. So the common cycle, this is very, very similar to what was in the homework thing, but put in a slightly different way. Load and examine the data, I think, is very crucial, right? Not just to load the data, but also to examine, right? And to examine, you can do what is, so all the examples we're going to do today, the notebooks are on the LMS, but and they do some basic viewing of the data, but I mean, you know how to view a data using standard print command in Python. And then the second one is normally called cleaning or transforming, wrangling, right? We have to get the data into the right format or the right shape, right? And this may involve various things like normalizing, feature extraction, and so on and so forth, deriving new features. And we will have a few examples of that in these three examples that we are doing, the case studies. Then creating training, validation, and test sets. So in today's examples, we will use scikit-learn's train test split to do this, right? And then, of course, we define the model and train it, right? Today, we are still going to use XGBoost for two of our examples, just because it's there in SageMaker, but maybe I may post something about how to train some model from sklearn or something. Then host and deploy the model, and then finally test the model, right? So I kept on saying remove the endpoint, right? This is really, really important. Yeah, so in business analytics, sometimes we have this standard idea of what we can use analytics for, but can all problems be solved? Well, not quite, right? So if there are problems where the past, where the future is not going to be like the past, right, then generally machine learning is not good. You still have algorithms for forecasting, right? Like for time series and things like that. And SageMaker also has those, right? But we are not covering them. But many problems can be, what can I say, can be helped by use of analytics. So we're going to look at three examples, a very mundane example, but it's an uncommon example, right? And that is, we will come to that example. Then the second one is a very common example, customer churn. And the third one is customer support, right? Which is based on text. So just to have an idea of that. And of course, we know that we generally make these kind of decisions. Humans make these decisions, and often they are not consistent. But if there's a good person, let's say the purchasing officer who makes really good decisions, right? And that person leaves, right? So that entire knowledge base lives with that person, right? So this whole area of knowledge management is about how do you transfer that knowledge? And it's not easy. There's no clear way to transfer the knowledge experience from one person to the next. We say there should be, I don't know, overlap of 1 month where you teach the person and so on. But it's quite unrealistic to expect someone to, teach 10 years of experience in 1 month or something like that. So, so that's why machine learning models also serve as kind of knowledge management aids, right? So if you store the data in some way, and that's probably the message. I mean, some of you may work in companies where, or you may have a startup, right, where this is your area, and then one of the things is you need to go and ask. I mean, the company very often they just want we want AI in our company, right? So they don't, I mean, they just know it as like a magic bullet. So you go and then ask, what is the data you have? And mostly they will say, we don't really have much data, but actually they may be sitting on a lot of data that they are not utilizing. But also there may be a case where they could, by adding something that is very obvious into the data set, make it usable, more usable, right? And so past data and how it is stored, or what attributes are stored, is really, really, really important. So here's this mundane example, right? Supporting decisions of a purchasing officer. So these about employees, right? Employees in a company can make requisitions, right? Usually to inventory guy or the purchasing officer or whatever. And if it's not in the inventory, then they need to figure out to get approval and then order it or whatever, or send it to a technical advisor, right? So with experience, this purchasing officer knows which ones to just send to for financial approval and which ones need a separate technical approval. I mean, so obviously any equipment, for instance, needs a technical approval, right? But maybe not all equipment, like, I don't know, so a USB stick or something doesn't need a technical approval, I guess, right? So access to the past decisions, let's say this person is very experienced, if they have all the records of the requests, and somewhere obviously they have a record whether they sent it for technical approval or not, right? A binary decision. Then you can combine those two to form a labeled data set, and that's what we need for supervised learning, at least, right? So we are only talking about supervised learning at this point. And then there are many algorithms. I think that link shows about 15, but as I said, they don't need to reinvent the wheel. So you have access to, if you use the Jupyter framework, you have access to all the algorithms of other libraries, including, I don't know, Hugging Face and things like that. All right, so the first thing before we actually, so in the previous tutorial of Amazon, everything was inside, and so you didn't really have to do very much. But let's say if you are doing something from out, well, if you're doing something from scratch, right? We need to have a place to store the data and the code, right? So you can, for today's examples, for instance, I don't know, you can set up namespace, I don't know, business analytics, or I don't know, this is called IS 4116 or something. You may think, okay, this is too generic. I may go to a job that has business analytics, and then I don't want that because this space is, you know, going to be under your name. Or you can, you know, so I've used course examples as the way I am delivering the data and the code to you on the LMS. So the two main things is to create a S3 bucket. This is the simplest kind of data store, right? And since we are only using CSVs and we are not using any database, right? This is where we will store things. So if you already created an S3 bucket, that is in the previous thing, you can use the same one and then put today's data set into it. Otherwise, you create a new one in a hands-on. Let's try to do this together. And then we load the code that is in the notebook that I have also shared. And then we follow these 6 steps, right? What was given in the previous slide. Initially, of course, we need to have a look. So this is just to underline the fact that we need to have a look at the data. So here's the data of that purchasing officer. There's a request ID, a role, meaning whether it's technical or non-technical, and the products, the desk, keyboard, computer, and so on. And then the quantity, price, and total, right? So maybe some things, if there are small quantities or small prices, you know, so they may be different decisions. So we need to know that, right? So these are all it's a very simple data set, all the data that we have. And this is the label, right? So we have not sent the desk or the keyboards, even 9 keyboards, we haven't sent it to tech approval, but computer we have. And then again, these things, again, computer we have, and so on. Of course, if this data set is, this is all, then all we can learn is, if it is a computer, we send to tech approval, right? However, that already there is these technical, okay, this I'm not quite sure what this tech, non-tech is now. Right, but let's do hands-on. So I want you to download that today's hands-on, and then let's do this together. Okay, so well, I guess log out and log back in or something. So if you go to AWS, you will be asked to log in, and last time I have said how to create an account. So I'm not going to go into that, right? And there will be a captcha usually. And so you come into this, you may have not have recently visited, but it's very easy to, so this is just like, you know, in most of our applications like Office, you have recent files or something, right? So you don't need that because there are so many services. There is actually a search engine, right? Because of course it doesn't only search services, it also searches the blogs and the documentation and so on. So initially we are going to just type S3 because we need to create an S3 bucket here, and I'm going to the main item, but you can go to those sub items also if you already have. And so we are going to just create a bucket, right? So let me say, I'll say course examples. Actually, course examples as 2 E's, but when you write it like that, it looks course E examples. So I just said course examples. You can select, obviously, it says Asia Pacific, you know, you should select these, right? Because they may be closer to you, right? Now that geographical closeness and the number of network hops may not be exactly related. So can anyone, whether you used Amazon or Azure or anything else, can anyone give me any experiences you've had out of the US ones? I mean, obviously it's to do with the number of users, right? Very often, most of the providers here had better connections to the US than to India, for instance, right? But that may have changed, and so this is based on experience. You can try this Mumbai one, right? Or the Singapore one, because some of our providers have a one hop to Singapore. Or you can leave the default, right? It doesn't make a very, very big difference. Right. And here there's a thing called choose bucket. That means if you want the same settings as a previous bucket you have, then you can say that. But for your intents and purposes, you just ignore all this and just say create bucket. Right. So we are leaving everything at default for the moment, at least. Right. And then this is the one I just created. So I'm going there, and then I need to upload my files, right? So I'm going to upload something that I have now put the LMS for the first example, which is this purchasing officer one, right? It's a very, very small file, right? And you can see here, as soon as I did it, it says 36.5 KB, right? And type is text CSV. and then I had to click upload. Right, so you can see now in my S3 course examples, namespace, I have orders with predicted value, CSV. Right. Right. So now I also want to that's a separate service of Amazon, but most of our work is going to be on SageMaker. So I go here and type SageMaker, right? And goes to the SageMaker dashboard. And now what I want is to have a new notebook, right? I can look at notebook instances that I have. Okay, so I have actually created one called purchase order just because otherwise it takes a little bit of time. But you can just click on this create notebook instance, right? And okay, let me do that for the second one. So I'm doing this for the second one, but you please do. We are going to look at we are going to look at the purchase order example, but now I'm saying I'm leaving this notebook instance type the default. And there are various configurations which I'm not going to use. Since last time I told you the importance of having the permissions, and for which you have an IAM role. Now here I'm going to use my my existing IAM role, but you can if it's the first time, you will have to create a new role, right? And then you can control all these, give users root access and disable and so on. But since I'm not giving anyone else access to this, I'm just saying give me root access, right? And then I'm going to create this notebook instance. Right now, since I didn't really okay, so it will take some time, right? So when you create a notebook instance, it's not just a matter of opening Jupyter or something, right? It has to run a virtual machine first, right? Create a virtual machine first. And then on top of that, run the your Jupyter environment. So here you can use Jupyter Lab or Jupyter. I suggest we just use Jupyter for now, right? So it will show that there is nothing there, right? So I need to upload my notebook, and that is also given in the LMS purchasing officer IP YNB, right? And so I need to upload it. Okay. So then I click on that notebook, to run my Jupyter Notebook, that particular Jupyter Notebook on my instance. There are many kernels here, right? What we want is only this Python 3, right? So you can do things like you saw already, PyTorch, TensorFlow, and PySpark, and so on, right? But I'm going to do, like in the Amazon tutorial, we are just using Python 3. Right, so here I need to, whatever the name you gave the data bucket, you need to put here. Okay, and whatever name you gave a directory inside that, you need to name here, right? And then inside that directory, we will have our file. Okay, because I want to go to the other examples, I'm just showing these are the common steps, right? We need pandas, which is our standard way to look at our data. Boto 3, I told you last time, is the way you access the S3. And the SageMaker, of course, is what the entire platform is. And there's a S3 file system. And we are also going to use scikit-learn, just not the whole of it. We are just going to, from the model selection, we are going to use the trains test split function only. And so these two, I need to get the role, right, which I have defined the IAM role, because that is what allows me to then use the services. And here now from the pandas, we can, because I've declared the data bucket subfolder dataset, actually these have to be changed to what I just uploaded, which I have forgotten myself now, right? You need to, you don't, so once you do it up here, these variables are there so that you can access all these using the variables. And so here we just do a head on the data frame, and you can see the data set that I showed in the slides, and you can figure out how large it is. And we see here that it is 100. You can just call shape also, right? And it will say what the shape of it is. So 1, 2, 3, 4, 5, 6, 7, 8 by 100, by 1000 or 1000 by 8. But we are also looking at the counts of the first column, right, which is the label, right? And we see that there are 807 zeros. That means there was no technical approval required, and 193 where it was required. So the first thing is to get the data into right shape. And so we have done some let's see, what did we do here? I forgot. Okay. Okay. So we have made this request ID a variable, right? So you can see the reason being that we are now trying to you can see the difference between this and this data set is only the request IDs for a large number. So again, it's good to, okay, so here you see there are 111 columns, right? So that means 111 minus some amount are all request IDs. Okay. So these data preparation things are common with what you may have done in general for data mining or machine learning. So I'm basically, you need to do what you need to get the data in the shape that you want to be able to make a predictive model. So the label is the first column. This corner one is not a column, right? It's just a serial number. And then we are going to use the train test split function of from scikit-learn to pass our data and to say that to use 30% for testing, right? And then again we use the that validation and test, right? So here the train becomes 70%, validation and test becomes 30%. Then we take the validation and test and divide again into 1/3 and 2/3. So test will be 1/3 and validation will be 2/3. And then we set the those data sets with by removing the headers, and we are writing to CSV files so that we can use it with S3, right? So once we write these training, validation, and test data, it goes into the same subfolder where we had the data file. So here we are then reading it into S3, right? Okay, and then we define our model. So here we can see we are doing actually the same thing that we did in the same thing that the Amazon tutorial does, basically using XGBoost. And for training, we are using a larger machine. And then you should get this kind of output. And after training, yeah, it says how long it took and how it will be built. And then we need to host the model. So again, in the Amazon tutorial also, I think we did this. We are deploying the model in this endpoint. Right, endpoint name here we are saying order approval. So we need to delete all those endpoints at the end. And then we basically test the model, right, by sending our test data. Right. So in the training step, it will also do the validation, training and validation within the validation set, and then the test set we use. And here we have printed the first 10 lines. Right. And here we have printed the mean accuracy, and we are getting a very good accuracy here. At the end, we need to remember to remove the endpoint. Okay, so so that was the purchasing officer, but we have the other two. I will just very quickly explain them before, and then we will have a kind of a joint hands-on session. Okay, so if you thought about that example is like, something so common, so nobody will think that we need analytics for that, right? But you can see that even a common mundane thing like that, which a human does normally, uh, can be learned to be more consistently done by an algorithm. And this is where the whole the ethics debate is coming in, right? So does that mean that purchasing officer is redundant, right? Um, and you will be surprised because in the past, with automation, the so-called third industrial revolution with computers, we kind of replace some people. For instance, we don't need the lift operator, right? I mean, obviously, you may not, none of you may have seen, but there are still a few remaining old government buildings where there is a person who sits inside the lift and presses those numbers for you, right? That's probably a very dehumanizing job. And so we say, okay, it was good that that was replaced with automation, right? Then now when it comes to, okay, purchasing officer, these are like people who work with us, right? Now, if they can be replaced with this algorithm, then that becomes a bit more serious. But as we go on, we will see that we can replace higher and higher level people we think are doing higher and higher level tasks, right? Right up to medical diagnosis, right? Accounting, medical diagnosis, things like that. The hardest things to kind of automate are things that require kind of creativity and things like that. So I just want to make sure that as IAS students, you also need to be holistic, right? So you need to think about the whole situation. So it's a very important debate on ethical use of these technologies. Helping predict customer churn. By the way, this is such a common thing. I won't spend much time. You use the customer buying patterns as a predictor whether they are going to churn. That means they are going to go to another supplier, right? So, for instance, let's say Carlos is, I don't know, a pizza guy or a baker or something like that. So you have this, and that's the kind of person we should empower, right? No point going and trying to, automate the functions of John Keels or something, right? But if there is a SME who can benefit by this and you have the knowledge, then that may be like a worthwhile thing to do. Now, a big problem there is that they won't know that it can be done. So you need to make them aware. But on the other hand, they may consider that this is like magic and it can, do them good even if they don't worry about from where the data comes. So what needs to be stored is really, really crucial, and how it is to be annotated, labeled, is as crucial, right? So, and in this is a typical example where you can't use the data straight away. It requires some normalizing because customers, there will be some customers who spend a lot, some customers who spend a little, and you don't want that to be, obviously you want everybody to spend more, but everybody doesn't have the same buying power. So what you want to know is We don't want to compare one with another. That may be required if you want to do some promotion or something like that. But here we want to only predict churn. So someone who was, I don't know, spending 10,000 rupees every week, and somebody who spends 1,000 rupees every week, doesn't matter, right? That may be their purchasing power. And so we, if the 10,000 person goes to 1,000, then of course there is a issue. Or if the 1,000 person, goes to 100 or doesn't buy and so on, then there is an issue, right? So we need to do some normalizing, and then we need to do something. We still can't use the normalized data because we need to know what is the change, right? So 10,000, then 9,000, 8,000, 11,000, and so on, no problem. But suddenly, let's say it comes to 5,000, then there could be an issue there, right? It could be a binary problem, right? This guy is going to churn or not. And here it is basically this decision, call or not. So call means, that means that your algorithm said he's going to churn, right? But you can have more than two class, right? So let's say this is a supermarket, and then the person was spending some amount X every week, and then suddenly it became X over 2 or X over 3 or something like that. That means for some products, they are going to some other place, right? So you may say, right, we want to have more than two categories. So one is where the customer is fine. One is where customer loyalty got divided, and one is where it's going to churn. So you can have a multi-class classification. We do the same thing, upload the data and the notebook, and then we follow that common cycle. Right, so this is what the data looks like. We have a customer code and the name. Obviously, this is, if you're into database, then this is not normalized, but this is a CSV file, the date and the amount, right? And so let's very quickly look at that as a second example. Okay, so again, you need to figure out the bucket name and the folder inside the bucket and the data set name. Pretty much the same. Pretty much the same imports, right, as the previous case. The pandas data frame, right? So this gives, and you can scroll to the right to see what the data is. And this is the shape. So this has 3,000 records. Most of them are not going to churn, but there are a few that churned. Most of them didn't churn, and so because it's past data, right? 166 of them churned. So you want to know those 166, what were the telltale signs, right? So here we are dropping things like ID, customer code, customer name, and so on, right? For the model, those are not going to be useful. And then we are going to divide again using train test split using scikit-learn. And so here it says, and in addition, we're going to print, right? So always good to have some print statements, right? Instead of just relying on this 30%. So here 30% split, we know when you have 3,000 and 30% split, well, we know roughly how much the test data is going to be. But so here we are printing the train, validation, and test shapes. So the training data has just over 1,000, and the other two have about 900, right? And those are split between the validation and test as 600 and 300. And we have 9 attributes. And how they divide, how the 2099 divide is 1,983 are didn't churn, 116 churned, and in the train set, and the validation and the test set. This is because sklearn does okay, in this case, it's a stratified sample, and so that's why if you did a random sample, you may not have got this. Right? So this is stratified by saying stratified yes. Like the stratified is y, that is by the churned number, and that is why it has divided them. Otherwise, you may not have got a very good distribution for validation and test. It's another important thing. And then the next step is, of course, to read it, write it from sklearn and read it to test3. And then the model, as I said, here we are going to use the same model because it's built in SageMaker, but we are changing some parameters here, right? Like the objective functions, evaluate metric, and so on. And you can, yeah, so you can see these things are very fast and only a small number of billable seconds. And then we host the service on the endpoint, right? And then we test using our test data set from S3. And we are printing the first 10 rows of the predictions. Here's the actual, and this corner is the predicted. So in this particular 10 examples, it's all correct, right? But overall, it's a 94% right, accuracy. This is just saying, this is just showing if I have y like this and predictor like this, this is the confusion matrix, right? So, but the real confusion matrix is this. So 267 non-churns have been predicted properly. 17 churns have been predicted properly, but 16 non-churns have been predicted as churns. Right? So in other words, so the precision is very, precision here with non-churns is very high, right? Because out of 267, all 267 have been, all the 267 that are told to be non-churn are non-churn. But the prediction for the churn is not so good, right? So, or the recall is also not so good. So out of 283, we have found only 267, right? And so on. Okay, this is a reminder to remove the endpoint. And after the final example, you can actually do this. We can do this together, right? Okay, so the last one is responding to customer tickets. Basic question that needs to be automated is it a frequently asked question? In which case we don't have to really involve a human, right? Or should it be escalated? So to a human. Now, we are not in this particular example going to say to whom, but that can be, right? So here it's a binary classification. Is it a free, is it a common question or not? And that determines whether the support person sends it to an automated response or to actual person. Right? This also is something that is relevant to chatbots. So basically a chatbot is trying to replace this customer support person, right? And has access to some knowledge base and has access to a knowledge base from which it can answer automatically, or it knows that it doesn't have that knowledge and so has to contact actual person. To whom is it can be another question. So where you have different types of question that can be supported by different divisions, right, in your company. That would be a multi-class classifier then. But this task is again only a binary. But the main difference in this task is that the data is text, right? And a common way people collect data now, collect Twitter, collect customer tickets is using Twitter, for instance. So they'll have a Twitter handle and people can either mention it or direct things to it. And so there is actually a Kaggle data set of tweets from to top global companies, right, like Apple and Warner Brothers and so on, right? So that data set is a little big, right, bigger than the other things. And then, of course, the transforming text is a key thing here, right, because all our algorithms work on numbers, right? And so we need to convert our text into numeric vectors, and generally we do this using some method like embedding, right? And in this example, we are using the popular word-to-vec embedding. And we do the same things. We upload the data and the code that is for this hands-on, and then we follow that common cycle. Right, so this is typically what the data looks like. There's a tweet ID and an author. So you can see that all these tweets have been by the same author. When was it created? And not sure whether this is used, but this is the main ticket, right? So these people have said something, right? And sorry, so this is the company, right? So for Apple, it will say Apple, and Amazon, it will say Amazon, and so on. And we have the labels, right? For this was a very easy thing and could be answered using an FAQ, so false. This one is a bit of a more serious thing and can't be answered by FAQ, so this has to be escalated to some person and so on. This one actually is just giving information, right? So, so you can imagine that out of these, how do you figure out information giving versus information requesting like this? And how do you propose we do that? Like that's a question, whereas this one is not a question, right? So you may have, you can imagine that this task can be a bit more complex than this. So very quickly to show the workflow, which is very, very similar. The basic steps are exactly the same. Which is to set up again the data bucket, the subfolder, and the data set. And the same things we are using JSON output for this. So, and we are using NLTK for doing some pre-processing, right? Again, we're just looking at the data by putting it in a pandas frame. And we see here that there are 520,000 records, right? And 417,000 of these have been not sent up to a human, right? So they are like in the FAQ, and presumably they could be directly referred to, right, to the relevant FAQ section. 102, nearly 103,000 have been referred to a human. So we have the same train test split here. And so you note here that there is, we are only having the training and validation set, right? We are only having the training and validation set. And this is common, particularly in deep learning, for instance. Okay, I probably should give an example of deep learning using Keras or something like that also. As I said, since all your assignments are finished, all this is for, you know, lifelong learning rather than for being tested at the exam, right? Okay, so here we are doing some we are using NLTK to tokenize. So there is a fair amount of pre-processing to do when it is text, right? So here, for instance, you can see, right, we are we have like @ and well, normally Twitter data is fairly noisy, right? Let me see, I'm not quite, I can't remember exactly what this does. Two kinds of labels, okay, these are label 1 and 2. For sentiment, it says, okay, I have forgotten what exactly this okay, I'll leave it to you. We can have, I will also set up a discussion forum in this last section for people to ask questions. And then we are using, we are loading the validation and training set. And then we are reading that into S3, using S3, and then we are training a model, and here we can see that the model name is called Blazing Text. You can refer Blazing Text, I mean, on Google or on Amazon, and it will say that it's an implementation of Word2Vec, right? And then we train our model and then host the model, right? So these things are the same steps as we did before. And then we test the model, right? So here the thing is to know whether, okay, so, okay, I think somewhere here we have, we are doing sentiment analysis, then escalation. I have forgotten this example really. You can, so here what is predicted is of course the label 0, label 1, which is the sentiment, right? So label 0 here is it's not very well commented here, but you can have a look at the data and see whether which one is positive and which one is negative. So this is predicting label 0. You can put some other text here and see what the predictions are. And then be sure to remove your endpoint. Okay, so these are just 3 examples, but what can you do with going forward? So the first one is, of course, what algorithms can be used. So if you click that link, it will show the built-in native SageMaker implementations of algorithms, right? And then you may have a question, can you run SageMaker locally? That's either on your laptop or let's say on your company or university server. And that is possible, right? So you can, these, once you establish the handshake, you are able to run these same things remotely on your machine, right? So you can install SageMaker as, you know, the normal way, Conda installs SageMaker and so on. I forget whether you have to change the repository. How can the application be shared online? So though you deploy that to an endpoint that is not accessible to the world, right? It is accessible to you. So I have uploaded in the LMS a small document on serving your application or deploying your application online. How can the best algorithm be figured out? Okay, so there's a thing called AutoML, and SageMaker does allow, and some of these things, of course, as Niroshanan said, some of these things are charged, right? But this is for your knowledge. So what AutoML does is it tries to fit lots of models. Well, it has some heuristics to determine based on your data set which kind of algorithms to try, and then it tries many of them, and then it says it gives you the best one to use for that particular problem, right? So AutoML has become very hot topic. Now, actually, before this, maybe I should have put something like, sorry. I will show it not in presentation mode, right? Which algorithms can be used? How can deep learning so these are like using TensorFlow, Keras, this kind of thing, right? Or even yeah, sklearn doesn't have. How can the application be shared online? So you, how do you deploy the model for, for real, right? And of course, then you go into a different costing model, right? So the business can provide this service, right, to its customers, for instance. How can the best algorithm figure out? How can a whole cluster be used for distributable? So one of the reasons why we go to a cloud-based service, well, one is the accessibility of lots of algorithms and data store and things like that. But another, and then also access to GPUs and things like that. And then the other is, of course, to do distributed processing, for large jobs. So, I mean, you can imagine SLT or Dialog bill month-end bill processing for millions of customers, right? How can that be deployed using something like Spark? And you saw already we selected Python 3, but there was a PySpark environment, right? A template, and that means if you use that, you have access to the Spark, which is used to distribute your work on a cluster. And then how can all this be done, let's say on Google or Microsoft or IBM? So there are equivalent ways in which you can use these other services. And by and large, what you need to do is to follow that same common cycle, right? So apart from our normal machine learning cycle, where we do the other things, right? The beginning and the end are what is different. The beginning is where you define your resources, right? On the one hand, your storage resources, and we have been doing it on S3, but if it's a database, then you will have to use their database or data warehouse service. They call Redshift, but and then you have to define your virtual machine, instance, right? That's at the beginning, and then the steps are common with the rest of the cycle, analytic cycle. So you load the data, clean the data, transform the data, then divide into train, validation, test. Then you basically fit a model, right? And so the fine tuning using the validation is done in the background, right? And then you in this cycle, then you in the typical cycle, if you're just doing for experimentation, after that you apply the test set, right? And that gives you a rough idea of how it performs. Here we actually deploy the model on an endpoint, right? That particular endpoint is for our use, right? And once you deploy it, we use the test data to test the model. That endpoint is for our use, but if you want to expose it to the internet, then that you need to have an API, and you need to do a lot of things normally. But in the handout that I've uploaded on the LMS, you can see that Amazon have made that easy as well, so that with some drop downs and point and clicks, you can actually deploy your model online for public use, right? Okay, right. So so that's you have still half an hour. For those of you who have not
so enabling other people to access and
done the
analyze the data. Then we need to have another here for helping the people actually to interact.
tutorial. You can do that,
and,
right? Well, for everyone, you would have to, of course, create an AWS account, and then after that, you need to do that tutorial, Amazon tutorial. For those of you who think that you know that probably is you can skip that. You can try out today's examples, and I will also try to upload at least one example of using a different library like sklearn, scikit-learn, and also one example of using deep learning. So two more examples I will upload. Okay, so I'm not quite sure if you want to go into groups and have a go at this at the just for the next half an hour, or let me take a show of hands. How many of you would like to go into groups and do this part of hands-on? Can you raise your hands? Okay, so my conclusion is that everybody is thinking about either their projects or their exams, or of course maybe assignments. So for this course, you have finished all assignments, so there is no work, right? Can a few of you say which it is? Whether so none of you put your hands up. So is it because of your project, or is it because of assignments, or is it that you are trying to study for the exams? Okay, let me take a show of hands. How many think that they don't want to do this because they are kind of trying to finish other assignments? Because of other assignments, can you raise your hand if that's the reason why you want probably to finish in the 90 minutes that we normally use? Anyone has like lots of assignments they have to submit? No, so that is also not the case. Probably still too early for studying the exam, so I'm not going to ask that question. Well, if you don't select the other one, I will ask. How many of you want to go back to your projects, and that's the reason why you don't want to have a group session? Can you raise your hand? So that means all of you want to study for the exams. Is that the correct? Can you raise your hands if it is for the exams? Oh my gosh, it's not because of anything. So it's something else. It's something else. Can you raise your hand if it's something else? Or your looks like you're brain fatigued or something, right? Yes, why do you think it's not a good idea to go into a group time? Yes, he's hard at work according to his image, but I don't know whether he's having his breakfast in real life. Yes. Tilini, why don't you want to go to the group time? Sorry? I can hear you, but I can't hear your voice. So why do you think it's not a good idea to do the group session? Sorry?
So I think it's because of the we have all studied for our exam, so it's for me fine for go to that also.
Preparing for exams, okay, that's one reason. Chamoli?
Hello, sir.
Yeah.
Actually, sir, these days we are trying to prepare our exam. That's the main reason.
So, okay. When is your first paper?
31st, sir. January.
Okay, so that means you guys are finished with your projects?
Still doing, sir.
Okay, how is your the other assignments? All finished?
Only one remains, sir.
Okay, Tisara?
Hi, sir. Good morning, sir.
Tisar.
For the same reason, sir.
So what is, I mean, is it the project or the exams or the assignments? What is the biggest?
Because it's the exam.
Exam, okay. They've already gone into that. Iromi?
For us, of course, for my group, it's the research. We are trying to
Okay.
get something done before exam.
Right. Okay. Shashini?
Same reasons, working for research and exams as well.
Right. So it looks like most of you have no real worries about assignments, but the project and the exam. Tirumalan?
Just both the exam and the project.
Which is taking more time now.
We have only 1 week for the exam, so that's also
Okay. Right. Okay. So then let's finish. As I said, most of what we covered in these last 2 sessions, which should have been 3 actually, are for your future, and they're not really for, they're for general knowledge for the exam also, general knowledge for the exam, but they are not, I'm not going to test, which function call in SageMaker do you have to use for this and so on, right? So that's not the point. Is it should be common to all cloud services. Obviously, each of them will have different names for their services and so on, but those similar things are needed. And so I hope it will be useful for some of you, not all of you, maybe later in your careers. Okay, so good luck with the exams. And as I said, I may upload still maybe 2 examples from outside SageMaker, but using SageMaker, but not using the algorithms.
So we have a small issue, like we just want to know whether the task submissions are also taken as assignments in your course, because in one of the tasks, in task 2, most of us couldn't do it because we couldn't find the data set in the link provided. We added it to the discussion forum as well.
Okay. I have an assistant who has already marked it, I think. I will check that, and I didn't see this discussion, so it's in
task 2. Sir.
Yes, sir. I put it like a few days after the lecture. You said that you'll upload the data set, but then I think you forgot.
Okay. That one, right. Yes. Okay. So yeah. There are 3 components in the continuous in this section. That is task 1, assignment 1, which is a written assignment, and assignment 2. Yeah, those are the only 3 components. Yeah. Any other questions? But the for the whole course, there are other continuous assignments. So that whole thing comes to, I think, 30%, right? Yeah. Whereas for this course, it should have been 40 or 50%, but unfortunately, since it's a predefined, I mean, it is an existing course, that has been published as 30 and 70. So that's 70% will be from the exam. Okay, any other questions or comments? Right, so good luck with not only this exam, but all the exams and the assignments and your project. We finished till in 90 minutes. Okay.